All right, we're back doing problems number 1, 2, and 3 from your Algebra Chapter 10 practice test. Number 1 says determine whether the ordered pair 7, 9 is a solution to the system below, and we're going to show all our work, of course. So we have the system 3x plus 2y equals 7 and 5x plus 7y equals 9, and we're just testing to see, is this a solution? Is 7, 9 a solution? Well, if 7, 9 is a solution, then when we plug it into each of these equations, we'll get a statement that is true. So let's see what happens when we take 7, 9 and plug it into the top equation. We're plugging it in for 3x plus 2y equals 7, where we are replacing this x with the 7, because 7 is the x value, and we're replacing the y with 9, because 9 is the y value. So now we have 3 times 7 plus 2 times 9 equals 7. Well, that is 21 plus 18 equals 7. And if 21 plus 18 equals 7, then we will have a true statement, which means that the point works. However, we get 39 equals 7. And 39 does not equal 7. So when we plug in 7, 9 into the equation, we get a statement that is not true. So it is not a solution. And so 7, 9 is not a solution to the system. And we don't have to bother plugging that into the other equation because it didn't even satisfy the first equation. And in order for it to be a solution to the system, it has to work in both. Number 2, we have a system here. We are going to solve this system, and in this case we are going to use substitution. And we are going to use substitution because we know that x is equal to 2y plus 3. So what I'm going to do is I'm going to rewrite the top equation, 4x minus 3y equals negative 3. However, I'm not going to write x. I'm going to write 2y plus 3. Why? Or how come? Because x is the same thing as 2y plus 3. So this right here is the top equation. The only difference is instead of having x right here, I have 2y plus 3 because x is 2y plus 3. So now I'm going to distribute, combine like terms, and solve this equation to find out what number y is. So by distributing, I get 8y plus 12. The 8y comes from 4 times 2y, which is 8y. The 12 comes from 4 times 3, which is the positive 12. And the minus 3y is from the equation, as is the equals negative 3. Now I can combine like terms. 8y and minus 3y. 8y minus 3y is 5y plus 12 equals negative 3. If 5y plus 12 equals 3, I can subtract 12 on both sides of the equation and get 5y equals negative 15. And if 5y equals negative 15, then y must equal negative 3. But I'm not done because we have to find out what the value of x is. Now that we know that y is negative 3, we can take this value right here and plug it in for y in this bottom equation. We could do either the top or the bottom, but I'm going to pick the bottom because that's going to be easier, because all I have to do is plug in the negative 3 as we see here, and then just evaluate to find out what the value of x is. So x will be equal to 2 times negative 3 plus 3. And this right here, this equation, comes from the bottom equation in the original system. And I've replaced the y with a negative 3. How come? Because y is 3. So 2 times negative 3 plus 3, that is negative 3. Negative 6 plus 3, if we simplify this right here, which will be negative 3. So the solution to our system then, as an ordered pair, will be negative 3, negative 3. X is negative 3, and y is negative 3 also. Problem number 3, another system here. This one we are not going to use substitution. We're not going to use graphing for sure, because we're not going to use substitution because we don't know what y is. We don't know what x is. Neither of these equations say y equals something or x equals something. We have two equations in standard form, but what we do notice here, or should notice, is that our y terms have opposite coefficients. We have a negative 3 and a positive 3. So if we add these equations together, again, sounds weird, but if we add these equations together, our y terms will cancel out and we'll be left with just x terms, and then we can solve for x. So by adding these like terms together, 4x and 7x, we get 11x. By adding the y terms together, we get 0, because negative 3 plus 3 is 0. And then by adding these terms together, the negative 50 and the negative 12, we get negative 62. So now, with no y's, we essentially have this equation, 11x equals negative 62. To solve this equation using algebra, we're going to divide both sides of the equation by 11 and find out, rounding to the nearest hundredth, that x will be equal to negative 5.64. How do you like that? A decimal. X equals negative 5.64. Another reason we wouldn't use graphing. I wouldn't be able to identify negative 5.64 in a graph. So we use our more sophisticated manner of solving using addition with these systems, with this system. So x is equal to negative 5.64. We're not done because we have to find out what y is. So take out your calculator because we're going to need to plug in negative 5.64 in for x, and this equation right here that just popped up is the top equation from the original system. The difference is I don't see an x here. I see a negative 5.64. How come? Yep, because x is negative 5.64. That's what we found out. So we do the arithmetic here, and we get negative 22.56. That comes from doing 4 times negative 5.64. Minus 3y equals negative 50. Using algebra to solve, I'm going to add 22.56 to both sides of this equation and get negative 3y equals negative 27.44. The negative 3y is right here, and the negative 27.44 comes from negative 50 plus 22.56, because we add 22.56 to both sides to eliminate it from the left-hand side. Divide both sides by negative 3, and we get y is equal to 9.15. Another decimal for you. So the solution to this system then, as an ordered pair, is negative 5.64, comma, 9.15.